we will see the one example to diagonalize the matrix. Example, obtain diagonal matrix of A, it is equals to 4 1 minus 8 minus 5. 4 1 minus 8 minus 5. Obtain diagonal matrix of A 4 1 minus 8 minus 5. Now we have to find out the diagonal matrix of the A. Now for this one we will see the solution. Okay, in the solution, in the step 1 we have to find out eigenvalues. Eigenvalues, that is lambda. Then step 2 we have to find out eigen vectors, that is v1 v2. Then step 3 modal matrix P, it is equals to v1 v2, v1 v2. And in the step 4 diagonal matrix D, it is equals to P inverse A into P. We have to use this formula. We have to use this formula to find out the diagonal matrix, that is P inverse A into P. So these are the 4 steps. First we have to find out the eigenvalues, that is lambda. In the step 2 eigenvectors, that is v1 and v2. In the step 3, that is the modal matrix P, that is v1 and v2. And in the step 4 we have to find out the diagonal matrix, that is D, it is equals to P inverse A into P. A into P. Now first we will see the step 1, that is eigen values, that is lambda. Dimension of A is 2 by 2. So we have 2 eigenvalues. So we have 2 eigenvalues, lambda 1 and lambda 2. So we have 2 eigenvalues, that is lambda 1 and lambda 2. Now see here, for this one we will have the equation, that is lambda I minus A, it is equals to 0. Lambda I minus A, it is equals to 0. So this lambda I, here the matrix is 2 by 2. Here the matrix is 2 by 2. So this lambda A will be lambda 0, 0 and lambda. It is also 2 by 2 matrix. It is also 2 by 2 matrix minus A. A is a given matrix, that is 4, 1, minus 8, minus 5. It is equals to 0. It is equals to 0. Lambda I minus A, it is equals to 0. So now we will perform the subtraction. We will perform the subtraction. So this is lambda minus 4 and 0 minus 1. So that is minus 1. And this is 0 minus 8, that means it is 8. And this is lambda minus 5, that means it is lambda plus 5. It is equals to 0. It is equals to 0. Now we will solve this one. So we will get lambda minus 4 multiplied by lambda plus 5, and this is 8 into minus 1, that is minus 8 minus plus 8, it is equals to 0. It is equals to 0. So this becomes lambda square plus lambda minus 20 plus 8, it is equals to 0. We will solve this one. Lambda minus 4 into lambda minus 5, that becomes lambda square plus lambda minus 20 plus 8, it is equals to 0. So we have, that is lambda square plus lambda minus 20 plus 8. Minus 20 plus 8, that is minus 12, it is equals to 0. it is equals to 0. Now lambda square plus lambda minus 12 it is equals to 0. This we have. Now we will find out the roots of this one. So this becomes lambda minus 3 into lambda plus 4 it is equals to 0. Lambda minus 3 plus lambda plus 4 it is equals to 0. Therefore eigenvalues are lambda 1 it is equals to 3 and lambda 2 it is equals to minus 4. These are my lambda values or the eigenvalues. Eigenvalues are lambda 1 it is equals to 3 and lambda 2 it is equals to minus 4. Now we have the lambda values, we have the eigenvalues. Now first step that we have calculated, lambda 1, step 1 it is equals to eigenvalues. This we have calculated, lambda 1 it is equals to 3 and lambda 2 it is equals to minus 4. This we have calculated. From these values now we will calculate the eigenvectors in the step 2. Now see here, we will see the step 2. We will see the step 2. Eigenvectors. Now we have lambda 1 and lambda 2. So we will have the two eigenvectors. For lambda 1 we have v1 and for lambda 2 we have v2. For lambda 1 it is equals to v1 and for lambda 2 it is equals to v2. The equation is lambda I minus a multiplied by x it is equals to 0. It is equals to 0. This is my equation A. Put lambda it is equals to 3 in equation A. Lambda I minus a, that we know. Lambda I minus a it is equals to how much? Lambda minus 4 minus 1 8 lambda plus 5. Now in this equation let's say in this equation what is the lambda value? Lambda it is equals to 3. So 3 minus 4 that is minus 1 minus 1. So here we have minus 1 minus 1. Then 8 and 3 plus 5 that is 8. So here we have 8 and here we have 8 multiplied by this x. X means our state vectors or the state variable. It is equals to 0. It is equals to 0. So after solving these ones we get minus x1 minus x2 it is equals to 0. So we can write down x1 it is equals to minus x2. X1 it is equals to minus x2. And from the second equations we get 8x1 plus 8x2 it is equals to 0. So again we get x1 it is equals to minus x2. Both the equations that we have the same values. Now see here, from this equation assume x2 it is equals to 1. Therefore x1 it is equals to minus x2 it is equals to minus 1. So we have the eigenvectors v1 it is equals to, what is x1? That is minus 1. So this is minus 1 and what is x2? That is 1. So we have 1 here. So v1 it is equals to minus 1 and 1. v1 it is equals to minus 1 and 1. Sorry. So I have assumed this one. Because I have the two equation. And for the lambda 1 x1 cannot be 0. It should be non-zero. So when the x1 will be non-zero, if x2 is not 0. So I have assumed that x2 it is equals to 1. So I have got x1 it is equals to minus 1, which is a non-zero value. So I got v1 it is equals to minus 1 and 1. This is my first eigenvector. Now put lambda it is equals to minus 4. See here, lambda it is equals to minus 4 in equation A. That means in this equation. lambda I minus A into X. Now see here, lambda I minus A, that is lambda minus 4 minus 1, 8 lambda plus 5. Now we have to put lambda minus 4. Minus 4 minus 4, that is minus 8. So here we have minus 8 and this becomes minus 1. So here is minus 1. And then this 8 as it is. So we have 8 as it is. And this is lambda it is equals to minus 4. So this is minus 4 plus 5, that is 1. So we have 1 here. So we have 1 here multiplied by equation A. Equation is lambda I minus A into X. So X is X1 and X2. It is equals to 0. It is equals to 0. So we have this equation. So from these ones we can write down minus 8 into X1 minus X2. It is equals to 0. It is equals to 0. So here we get X1 it is equals to minus X2 divided by 8. Minus X2 divided by 8. This we have. Similarly here it is 8x1 and plus x2. It is equals to 0. It is equals to 0. So here also x1 it is equals to minus x2 divided by 8. Minus x2 divided by 8. Now see here. I want x1 must be x2 must be non-zero. X2 must be non-zero. So assume x2 it is equals to 8. X2 it is equals to 8. X2 it is equals to 8. So x1 it is equals to minus x2 by 8. So that means minus 8 divided by 8. It is equals to minus 1. It is equals to minus 1. So now I know x1 it is equals to minus 1 and x2 it is equals to minus 8. So eigenvectors V2 it is equals to, see here, eigenvectors, that is x1 and x2. So what is x1? That is minus 1. So here is minus 1. And what is x2? That is 8. So we have 8. So these are my eigenvectors. This is my first eigenvector. This is my first eigenvectors and this is my second eigenvector. This is my second eigenvectors. Now see here in this one we got the equation x1 it is equals to minus x2 by 8. Minus x2 by 8. Here also you can assume any value of the x2 more than 0. We can assume x2 it is equals to 1 also. So what will be the x1? That is minus 1 by 8. Minus 1 by 8. But for the simplicity I have assumed it is x2 it is equals to 8. So 8 divided by 8 becomes 1. So here is the minus sign. So I got here minus 1. So I got here minus 1. So to make the calculation simple, I have assumed that x2 it is equals to 8. X2 it is equals to 8. So I put the x2 it is equals to 8 in the equation. So minus 8 divided by 8, that is minus 1. So I got x1 it is equals to minus 1 and x2 becomes 8. So I have the vector v2 it is equals to minus 1 divided by minus 1 and 8. So this is my second eigenvector. So now I have the two lambda values, that is lambda 1, lambda 2 and the corresponding v1 and v2 that we have calculated. Now we will see the modal matrix. Step 3. See, step 1 and step 2 that we have completed. Now we will see the modal matrix, that is P. P it is equals to what? V1 and V2. V1 and V2. Step 3. Step 3, that is modal matrix. That is modal matrix. P it is equals to V1, V2. V1, V2. So it is equals to, what is V1? V1 it is equals to minus 1 and 1. So this is minus 1 and 1. This is minus 1 and 1. And what is V2? Minus 1 and 8. Minus 1 and 8. So I have P it is equals to minus 1, 1, minus 1, 8. So that means I have the matrix P it is equals to, minus 1, minus 1, 1 and 8. So this is my P matrix, or we called it as a modal matrix, Now see here, modal matrix is known. Now see, in the step 4 we can calculate the diagonal matrix. What is the equation for the diagonal matrix? D it is equals to P inverse A into P. Now we know A, we know P. So from P we can calculate the P inverse, and hence we can calculate the diagonal matrix. Now in the step 4, we will see the diagonal matrix. Step 4, diagonal matrix. Diagonal matrix D equation is P inverse A into P. Calculate P inverse. What is the given P? What is the P that we have calculated? What is P? That is minus 1, 1, 8. Minus 1, 1 and 8. Minus 1, 1 and 8. This is my P matrix. P inverse, it is equals to, formula is adjunct of P and the determinant of P. Now determinant of P it is equals to, this is minus 1 into 8 minus 1 into minus 1. So this becomes minus 8 plus 1, it is equals to minus 7. So this is my determinant, that is minus 7. Determinant of P is minus 7. Now we will find out the adjunct of the P. It is equals to, it is very easy in the 2 by 2 matrix. Just you change the position of the minus 1 and 8. So here is the 8 and here is the minus 1. And change the sign of these two. Here is negative, so this becomes positive, and this is negative, this is positive, so this becomes negative. Adjunct of P for 2 by 2 matrix, you have to interchange the position of minus 1 and 8, these two elements, and we have to change the sign of these two elements. So by changing the position of these two, I got here 8 and here is minus 1, and by changing the sign of these ones, I got here 1 and here is minus 1. So here is 8, 1, minus 1, minus 1. This is my adjunct of P. So my P inverse, it is equals to, I know the formula, that is adjunct of P divided by determinant of P. Now see here, it is minus 1 by 7. So I can write down it is minus 1 by 7. 1 by P, na? So it is minus 1 by 7 multiplied by, what is my adjunct of P? That is 8, 1, minus 1 and minus 1. So this is my P inverse. Now I know the P inverse. Diagonal matrix D, it is equals to P inverse A into P. This formula. In this formula, now we know the P inverse, we know the A, and we know the P. So we will put the values into that one. Now my D becomes, what is my P inverse? That is minus 1 by 7 in bracket. Determinant matrix is 8, 1, minus 1, minus 1. Then what is my A? A is given. A is 4, 1, minus 8, minus 5. 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 And then what is my P? P is minus 1, 1, 8. Minus 1, 1 and 8. Now we have to multiply all this one. So my D becomes minus 1 by 7 as it is. This 8, 1, minus 1, minus 1 I will keep as it is. And now this first row and first column I will multiply. 4 into minus 1, that is minus 4, plus 1 into 1, that is 1. 4 into minus 1, that is minus 4, plus 1, that is minus 3. So here is the minus 3. So 4 into minus 1, that is minus 4, plus 1 into 8, that is 8, minus 4 plus 8, that is 4. So I will put here 4. Here is minus 8 into minus 1, that is 8. 8 minus 5, that is 3. So I will put here 3. See, this is minus 8 into minus 1, that is plus 8, and minus 5. Minus 5 into 1, that is minus 5. So plus 8 minus 5, that is 3. And here is the minus 1 into minus 8 into minus 1, that is plus 8. And here is minus 5 plus 8. Minus 5 into 8, that is 40. Minus 40. Minus 40 plus 8. So this becomes minus 32. So this becomes minus 32. See here, minus 8 into minus 1. So that is 8. And minus 5 into 8. That is minus 40. Minus 40 plus 8. That is minus 32. So here is minus 3 plus 4 plus 3 and minus 32. These are my values. Now I will further simplify. So this becomes minus 7. And here 8 into minus 3. That is minus 24. Plus 3, that is minus 21. That is minus 21. So here is the 8 into 4, that is 32, minus 32. Plus 32 minus 32, that becomes 0. So here I have 0. So here is minus 1 plus 3. Minus 1 minus 3, that is plus 3. And here is the minus 3. Plus 3 minus 3, that becomes 0. So I will put here 0. And this is minus 4. Minus 1 into 4, that is minus 4. Minus 4. And here is minus 1 into minus 32, that means plus 32. Plus 32 minus 4, that is 28. So I will put here this one. So now here D it is equals to, I will divide every elements by minus 7. So this minus gets cancelled. 21 divided by 7, that becomes 3. Okay. So anything divided by 0 multiplied by anything, so this becomes 0. So 0 multiplied by this one, so this becomes 0. And this is 28. 28 divided by, this is minus sign, so I will put here minus. And 28 divided by 7, so this becomes 4. So this is my diagonal matrix. So this is by diagonal matrix. Now see here, D it is equals to lambda 1, 0, 0 and lambda 2. See here, what is my values of the lambda 1? Lambda 1 it is equals to 3 and lambda 2 it is equals to minus 4. Is it coming? Lambda 1 it is equals to 3 and lambda 2 it is equals to minus 4. It is coming same. So that means our calculations are correct. That means our calculations are correct. What we have converted, what we have found out is correct. This one, for these ones, my lambda values are 3 and 4. And in the diagonality, that must be the value. That must be the value. And that we have proved mathematically. And my diagonal matrix is coming lambda 1, 0, 0 and lambda 2, which are same. Or here also we can write it is equals to lambda 1, 0, 0 and lambda 2. So lambda 1 it is equals to 3, that we have already got, and lambda 2 it is equals to minus 4, that we have already got over here. So it is coming lambda 1 it is equals to 3 and lambda 2 it is equals to minus 4. So this way we can diagonalize the given matrix. In this one it is simple. For the P inverse matrix, this is my formula, adjunct of P divided by determinant of P. To find out the adjunct of the P, we have to change the position of these two one. So this becomes 8 and here it becomes minus 1. So this is 8 and this is minus 1. And I have changed the sign of these two one. So this is minus plus. So I have put here 1. This is minus, so I have converted it into positive, that is plus 1. And this is positive, so I have put here negative. So that means it is minus 1. That is minus. So this way we got the adjunct of the P, and this determinant of P, that is simple, minus 1 into 8 minus in bracket plus 1 minus 1 multiplied by 1. So we have calculated here minus 1 into 8 minus in bracket 1 into minus 1. So minus 8 plus 1, that becomes minus 7. So I got the plus P, determinant of the P, and then we have calculated the D, it is equals to P inverse A into P, and this way we can got the diagonal matrix. Now the simple thing is that whenever we have to diagonalize the matrix, we have to remember the 4 steps. Step 1, step 2, step 3 and step 4. In the step 1, first we have to find out the eigenvalues. What is the formula? Lambda I minus A, it is equals to 0. In the eigenvalues, we have to find out the eigenvectors, that is V1, V2, if there are the 2 by 2. If it is 3, then we have V1, V2, V3. What is the formula for the eigenvectors? Lambda I minus a into x, it is equals to 0. X will be x1 x2 if it is 2 by 2. X will be x1 x2 x3 if it is 3 by 3. X1 x2 x3 x4 is there if it is 4 by 4 matrix. So it depends the values of the x1, the number of the x1. Here we have the 2 by 2 matrix, so that we have x1 and x2 only. So we have x1 and x2 only. Now in this equations lambda I minus a, we have to put the values of the lambda. What is the value of the lambda? Lambda it is equals to 3 and lambda it is equals to 4. So one by one we have substituted the values of the lambda in the equation. Substituted the values of the lambda in the equation. So lambda it is equals to 3, that is 3 minus 4, that is minus 1. So we got minus 1 and here is 8 as it is minus 3 plus 5. So we got here 8. So 8 and x1 x2. So we got the x1 x2 equations are there, and from these ones for the lambda 1 x1 should not be 0, it must be non-zero. So we have assumed the value of the x2 it is equals to 1, so we got x1 it is equals to minus 1. You can assume any value. You can assume x1 it is equals to 1, so your x2 will be minus 1. Same one. And similarly we have calculated the v2, that is minus 1, and that we got here. And then from that one we got the modal matrix, that is P it is equals to v1 and v2. That is my third step, v1 and v2. Once we got the P, then we can go for the diagonal matrix. D it is equals to P inverse A into P. So we get the we can calculate the P inverse first. The P is given, or the P that we have calculated, obtain this P, minus 1, 1 and 8, and from this ones P inverse that we have calculated and put the values, and then we get the D it is equals to 3 0 0 minus 4, that is nothing but lambda 1 0 0 lambda 2. So this way we have proved or calculated our diagonal matrix.